So welcome back to Kafkuba. I'm here with my son-in-law Joe, and I was on the phone with my daughter the other day, and it seems like they were having some problems with their pool. So Joe lost power to his pump, so he decided to change out the motor, and he did all that while it was leaking. And we just tried to tighten it, and it was still leaking, so we decided to back it all off and inspect what he had done. And it turns out that underneath this impeller, he had put on the motor shaft seal backwards, so the rubber grommet was rubbing against the ceramic pump motor end. And well, here's one here. He had it backwards, so the rubber end was rubbing against the ceramic seal on the motor, and then when we tried to back it off to flip it, we cracked the ceramic, holy sunlight, we cracked the ceramic bearing. You can see it's in two pieces. So fortunately he kept the old one in the garage, and we inspected it and it looked pretty good, and we washed it all off, and the wear was not bad, so we put it on properly. And we're gonna have Joe reassemble this motor back to the filter complex, and we're going to see if we fixed the leak. But that was just one issue. The main issue originally was we had lost, or he had reported losing pump power via the switch on the wall. So I'm going to walk you through the electrical stuff in a second, but he's got the pump powered separately through a homemade cable to a always-on receptacle down here, because the pump receptacle here is lost power. So just real quick, on the very end, see, I don't know anything about pool systems or filters, but you know, it's all electrical engineering, so you just have to spend some time looking at it and thinking about it, and everything has to be powered so you can start to reason how things work. But this is the pump receptacle that has no power, and coincidentally, as I start asking Joe a bunch of questions, he's telling me, oh, by the way, the light's not working either. So I'm like, oh, we got 4 different problems going on here, so hold on, let's slow down, let's revisit this whole thing. So yesterday I walked him through the system, and essentially there's a switch at the deck. It's a two switch box, and one switch controls the light and one switch controls the pump, the on pump. And then it goes, one standpipe goes down to the house and through the basement to the circuit breaker panel, and the other one comes down to this always on receptacle, and then the conduit runs to this junction box, and above that junction box is the chlorine generator control panel, and then out the other end of this junction box it runs to the pump power cable receptacle. And then this turns out at the end that it's the high to low voltage pool light transformer. And then out the other end here, it goes underground and runs to the pool where the women are sitting bullshitting and reading their books and have no interest in what we're doing over here. Hey, so I have a schematic. I laid in bed last night and thought this through, and I drew out a schematic that's in the house, but I just wanted to kind of walk you through the issues he was having. So bottom line is he lost power to the pump, thought it might be the pump, took it all apart, it looked corroded, so he decided to buy a new pump. But then we don't have power anyway. He's running it separately, and what I think is happening is, I opened this junction box yesterday and we were flipping the switch on and off. There's no voltage there, the panel's not coming on, the light's not coming on, and everything is run through the same conduit, so it's really kind of hard to get your brain around how everything's wired in parallel or separately through those switches. But I think I have a schematic inside that I think of what the previous owner had done. So whether he's wasted his money on a new pump or not, judging by the fact that it was kind of over. Last summer I noticed when I touched that pump, I couldn't even hold it. It was so hot. So I have a feeling it was overworking. He had this pump running today for about, I don't know, a half hour, and I could rest my hand on it no problem. So I don't think he did a bad thing by getting a new pump. I think it's going to be more efficient, and the flow was always slow last summer. So let us get the pump going, fix that leak, and I'll walk you through the schematic. And then I think the problem is in that switch or maybe something in the house that I haven't looked at close enough yet. So we'll get back to you. So while Joe's reassembling the pump, this is how the system looks outside. This is all like one conduit. So the down pipe from the switch goes under the deck and into the house. The switch on the left controls the pump, the one on the right controls the light. It goes into this receptacle that I was really confused about because it's always on. And I thought if there was no power in this junction box or at the transformer or at the pump receptacle, I went down the line, there was no power, no 120 volt, no 120 volt. But this one has voltage always on. So this is what it looks like along the wall outside the house. And I slept on this last night, and I think here's what's going on. I think the breaker panel in the house basement is supplying the power, and I think the previous owner, tapped this always-on receptacle upstream of the switch, so it's always got power, assuming the breaker's closed. And then, in parallel with that, the hot end goes to the switch. I'm simplifying things here, and this is kind of just a pictorial. And when you close the light switch, it bypasses everything and goes directly to the 120 volt AC to 12 volt AC through this transformer, and then goes underground to the light at the pool. You know, I didn't know anything about pool systems, but it makes sense now. You got a low voltage because, you know, you get some kind of leak, or, you know, you don't want to electrocute anybody in the pool, so you don't want 120 volts going, you know, anywhere alongside the pool. So they have this safety step down the voltage, plus it gives you galvanic isolation, and you got your pool light here. It would be a strange coincidence, by the way, if that bulb went out while everything else seemed to be failing. So I don't think it's the bulb, but, you know, the way the day's been going, or the last couple of days have been going, who knows. So the light switch bypasses all the other circuitry except for the return and the junction box. Now, if you close the pump switch, you got your chlorine generator panel, which I don't know anything about inside, and I don't really care because that's not presenting the problem, but it's in parallel with the pump receptacle there that the pump plugs into directly. And that's not getting power, the light's not coming on, and there's no voltage in the junction box. And there were indeed 3 wire nuts in the junction box. So I forget how many wires, but I think one of them definitely had 3. That makes sense. And I don't remember there being 4. I can't remember. So, but this is generally what's going on. And the fact that the switches aren't controlling anything and there's no power, I think the problem's upstream of the switch, either a bad switch or God forbid, something blew in this conduit and the wires melted. I don't think so, because the breaker never popped. So this is what the outside looks like, so we can continue troubleshooting a little more intelligently electrically what's going on. But I expected to come over and start tearing the switch apart and looking what might be wrong. And he was mucking with the pump, and that was still leaking. And then he, of course, had the seal reversed. So he's putting that back together. We're going to go see if we fix the leak, get the pump working, and then revisit this the source issue that I think is going on. So, after disassembling the pump and the mating plates and all the gaskets and breaking the brand new pump seal, as I mentioned in the first segment, Joe luckily found the old pump seal that was relatively good condition in the garage, and it wasn't broken. We cleaned it up and lubricated the shaft, and it slipped all together nice. He got it going back together, and there's no leak. So good job, Joe. We have flow, and the pump is running, and it's nice and cool and nice and quiet and no leak. So now we can get back to what I came here for, which is taking off this temporary power and getting it back to the receptacle that's switched, and everything I just explained in the schematic. So one problem solved, and let's see if I can electrocute myself with the remainder of this issue. So while Joe takes apart the switch box so we can access the wiring, I just want to touch on something real quick. The new motor that Joe temporarily wired has a switch in it for 230 or 115, and originally he was thinking this was 230 because it's got a strange looking three-prong. I don't know if you can see it with the light there, but it's got a strange looking three-prong. Where's the old cable, Joe?
It's in the garage.
All right. Anyway, he had just assumed this was 230, but as we went through it yesterday, we realized everything's 115. And when he temporarily rigged this to the receptacle, he did switch it to 115. So we now know it should be a 115 motor. So we were looking at the old motor just to get a feeling for what went wrong with it, and you know, the hookup side looks clean. I don't know what the lighting's like here because we're outside and I can barely see anything. Starting capacitor, it's very corroded. A whole bunch of anodized aluminum fell out of it when he was taking it apart, so he assumed it was all shit up. So I broke this. This is the same. This is the equivalent switch. The previous owner had it. Just looking, the previous owner had it on 230 because he didn't switch it, and I broke it. But you would select 115 like we did with the new pump. But he had it on 230. So now I'm scratching my head, and I'm wondering, you know, did I assume something wrong? Well, we looked at the label plate on the new motor, and you can see, I think, that it's rated for 230 or 115, and at 230 it draws 6.5 amps, and at 115 you double it because you're taking the voltage in half. Has 13 amps. So essentially what you have is a constant power motor, which is where was it? 1 horsepower motor. I don't know if you can catch this, but bear with me. It's a 1 horsepower motor. So at 230 volts it draws 6.5 amps, and at 115 it draws 13 amps. So now I'm wondering, oh man, what's going on here? Are we making some wrong assumptions? Because I don't want to pull through too much current through the house and the wiring. But then I realized, well, if you run like the previous owner had his motor set to 230 and it was plugged into 115, it's still going to want to run at 1 horsepower. And what you're doing is you're drawing twice as much current because you're running a motor on the 230 windings off of 115 volt supply, so it's going to try to draw the same current as the 115, which is 13. So essentially you're pushing 13 amps through the 230 volt windings in the motor that are only rated for 6.5 amps, which is probably why that thing was running so friggin' hot. So he might have installed the motor, the previous owner installed the right motor, but had it at 230 volt windings off a 115 volt supply, and it was running and probably burned out the motor after a couple seasons, and that's what happened. So I'm confident that we have the right motor switched to the right winding settings at 115 because everything here is wired at 115, and I think the previous owner slipped up. So I just wanted to have that little tangential lecture there. So back to what I came here for 3 hours ago. All right, so we've been here a couple hours, and some of my original assumptions were wrong, which probably isn't too surprising until you get digging through the wiring and wringing things out. I wasn't 100% sure, but we did have a source problem in the end. So this was a 120 volt circuit. We checked that out, and it was 120 volts when in the off position from the source side, and when we turned it on, the load side did indeed have 120 volt sources on it. But I was confused because the house wiring is coming from this other side, and that's when I started scratching my head as to what was really going on. Well, long story short, what I determined was this receptacle that's always on is fed independently through the house and the garage in parallel with another receptacle. That's why it was always on, and that power was used to come through this switch, then back down. So the hot lead went through the switch back down. The ground lead in that receptacle already went through that junction box over there and fed independently the lighting transformer at the end of the string. So the lighting transformer went through the motor connection box, but just passed through the back of it, through that junction panel, and was fed independently by this switch, and it was always working. So the light should work, but the light's not coming on, which coincidentally means the bulb's out. So that was just a strange coincidence. We got to this side, and I rang that all out, and I was really confused as to what was going on, because all the breakers in the house seemed to be fine. Went through the junction box, no voltage. Went to the motor connection, no voltage. Now, we decided to go down to the breaker box and check for a bad breaker, but before I show you that, my original assumption that this was all 120 volts was wrong, and that motor, even though it's running off 120 volts now, temporarily directly through this receptacle box, is good. What we ended up finding out was this is a 220 volt switch that is fed by a different breaker all its own in the breaker box. So that motor needs to be switched back to the 260 volt setting. It's running fine now at 115, but let's go down to the breaker box and we'll show you what happened. So when we realized we had a source issue upstairs and we sorted out the lighting circuit independently fed by the 115 volt receptacle, I said, well, let's go see if we have a bad breaker. So we took the red lead of the multimeter and the black lead to the ground strip, and each one of these checked out 120 volts. All the way down the row was fine. And then we got to this little bad boy down here, and we weren't getting any voltage. And then I realized it was tripped. I had never considered in my mind that I thought that was a 115 volt complete circuit upstairs. I never considered this because they weren't even labeled. But when we found out that this had no voltage, and the breaker had tripped, which tells me the motor probably did fail, we reset the breaker, checked the voltage, and then went back to the switch upstairs, and lo and behold, it was reading 220 or 240, whatever it was. So this breaker had tripped, and the pump and the panel are being fed by that. So yeah, and we verified with the multimeter the pump receptacle was now turning on and off with the switch. So everything should be good now. We just have to rewire the motor to the 230 volt winding and connect up that jumper cable, and we're good. Let's get this buttoned up. So just to revisit the schematic, I was wrong before. I was mistakenly led to believe this was the pump side. This is the light, pool light, and this was the pump side. And this didn't go to a 120 volt single pole breaker. It went to a 220 yoked breaker. And the receptacle was wired directly to an outlet in the garage. And it took a hot lead and went to the one side of the switch, and then the other side of the switch went back down through the conduit to this panel and fed the light transformer separately. So the source for that light transformer panel was this receptacle. That the hot lead was fed through this switch in series, and the pump circuit through the 240 volt breaker at the bottom of the breaker panel went through here and then back out through this side and out to the pump receptacle and chlorine generator panel. So this was all messed up. Some of my original assumptions were wrong, but that's essentially the idea. I had no idea that the light was fed directly by this receptacle until I started digging around the light switch panel. And you know, you really can't. So I rang out everything from the junction box panel to the panel light, and then when we figured out the breaker had tripped and verified this switch was okay to the pump, then in turn the pump receptacle did have 220 volts. So now we have to take the pump motor and put it back to so the original owner was correct. It was a 220 volt operating pump off of a separately fed yoked breaker. So I'm not going to redraw all this, but it just goes to show engineering a system you have no familiarity with. You make some assumptions, you get to the next step, and then you just spend more time verifying and using your multimeter and then scratching your head and revisiting your steps. There were some red herrings here. I was told one side was the light and one side was the pump, and it was actually the opposite. This receptacle, I had no idea was the source for one of the switches, and none of the breakers in the house were labeled. So I overlooked the tripped 220 volt breaker, and I didn't want to just start flipping things. So it was good to go through the whole thing and verify it. And Joe's out there. I retaped all the switches and made sure everything was electrically isolated, and he's just putting the tops back on. We got to remake the pump. I don't know that we have the a proper plugs and bushings I don't think we want to reuse the bushings to feed the pump, so he might have to do a little more work on his own to get this thing wrapped up, but that's the gist of it. Okay, we're all buttoned up with the switch. 4 or 5 hours later, we're all secured here. All the junction panel boxes are closed. We remade the end of the pump cable. Didn't show you, but we relugged it and bought a new I don't know, stuffing tube, I guess, for lack of better terms. And Joe just turned the breaker on and hit the switch, buddy. Oh wait, and we put the 260 volts. We put this back to 260 volts after we figured out, or 220 volts after we figured out it was a double full breaker. Go ahead, hit it. Baboom! We're up and running. The only mystery is the chlorine generator panel we're waiting for it to see if it turns back on. I didn't do anything with that. I would think it's fine. It might just need to be reset or something like that. Well, that was a mission accomplished and some lessons learned, but we're up and running. Good job, man.
Thanks. Much better, much cleaner.
And it only took me all day Sunday. And now I'm a pool expert. We're just gonna keep track of this chlorine generator, and Joe might have to figure out if it needs to be reset or it just needs to, I don't know. That's another project for another day, but this is the part I cared about. All right, this video's going on long enough. Take care. So just a little appendix to this story. The chlorine generator wasn't coming on. There was no power to the panel. So we opened the junction box again, and I stuck my fingers in there and it came back on. So we just redid a wire. The wire lug and the wire nut was suspect, and the wires weren't really in there secure. So we just redid it all. Go fire it up.
You want to put that box back on? Or
No, just hit the switch again, and let's just make sure everything. Yep, there we go. We have an 100% operable system now. Just too quick a job relugging or wire nutting something, and when you stuffed it in the box, it kind of came loose. So here we go. Thanks again for watching. You're welcome, my guy.
Thank you.